All right, we are live. Audio and video is up. Okay, exam review day. First off, a couple of housekeeping items. So homework 6.4 is due today. What I'm going to do is to ensure that you have something to go off of for the final, I'm going to post that solution a little bit later. But that's it for the homework. Hold on. Is anybody else getting audio? So you can hear me. Okay. You might want to log out and log in, Mr. Dara, because it looks like everybody else is getting the audio. But if there's anybody else who experiences any technical glitches, let me know. Okay, so a little bit on housekeeping. Homework 6.4 is due today. I'm going to post that solution a little bit later today, but that's going to be it for the homework. It's also going to be it for the homework this week. So maybe another announcement I should have mentioned, we are not having class on Friday, okay? No class on Friday. In fact, we're having our exam Wednesday, and then I'm going to give everybody off Friday for break. So my goal is to try and get that exam graded before break. I'd like to do that. I'm going to try and book through it and get through it as quick as I can. And I'll do the same thing. Yes, Mr. Spa said. I'll do the same thing that I did for the last two exams, where I will post the results of the exams on Teams, where we'll talk about the statistics and whatnot. And I'll also have some suggestions for the final and whatnot. And then I know it's always asked. I put the grade distribution on the exam. Just real quick on logistics. None of the logistics are going to change. It's all going to be kind of the same thing that we've been doing for the past couple of exams. We're going to start the exam at 1 p.m. on Wednesday. It's going to close at 2 p.m. on Wednesday. It's designed to be 50 minutes long, and I'll talk a little bit about the exam content here in a little bit. And you know the same deal as before. I'll have the timed exam and then the PDF, and then you can upload the PDF a little later, and I do that so that you all aren't rushed to get the PDF uploaded and do the exam and all that all at once. Okay, exam 3, the operation, the approved materials, just to be clear, it's a forced completion, so once you start, you have to complete the exam in one sitting. It's timed, it's a 60-minute timer, and it will auto-submit at the end. The questions appear all at once, so you all All right, how about now? Can you hear me? Okay, I don't know what happened. I was just rocking and rolling, and then I heard all these beeps in my ear from the chat, and then there was these, it was like a big buffering sign on my camera and mic. I don't know what happened there, but looks like everything's good. Going back to what I was saying about approved materials, open book, open notes. You can use any resource on Blackboard. You can't receive or give aid. You can't receive aid from another individual or give aid to another individual, and that does include like internet searches and whatnot. I know that it looked like there were some responses on some of the questions on the last exam that looked suspiciously like they were from the first page of a Wikipedia article. So let's not do that. And I don't think that it would particularly help on this exam anyways. So yeah, because I've fairly customized, yes, as Mr. Page said, I've fairly customized this exam, so I don't know that you're going to get any help on the internet even if you wanted it. But you don't need it. I don't think this is a particularly challenging exam. The exam will be comprised of 4 to 5 short answer conceptual questions, and again, short ones. And I'll go ahead and tell you 3 computational problems, not 2. And I'll even tell you kind of the class of those problems as we get through the review. Just do me a favor and type out an answer for every question, even the computational ones. It does help out with the grading. And don't just answer the question on your scratch work. It helps out a lot when I'm grading. Let's talk about the exam. I think you could probably parse out what the 3 computational questions are, and I'll talk about that as we get into the, no worries, no worries. Excuse me. So let's talk about the topics on the exam. So first off, centroids. You need to be able to locate the centroid of lines, areas, and volumes, and be able to compute the moment of inertia. That's, pretty much centroids in a nutshell. Structural analysis. I put here that you need to be able to compute support reactions. That wasn't technically one of our 2 structural analysis topics. We had 2 topics for structural analysis, and that was trusses and shear and moment diagrams. But for both of those topics, you can't compute, you can't analyze a truss if you don't know what the reactions are. And you can't draw a shear and moment diagram without the reaction. So you kind of need both, or kind of need reactions for both. So I went and go ahead and said, be able to compute support reactions for trusses and for shear and moment diagrams. That's the exam in terms of the content and the topics. So I'll go ahead and tell you in terms of parsing out. I mean, there were 3 main topics. There were centroids, the topic about centroids, the topic about trusses, and the topic about shear and moment diagrams. And there's 3 computational problems. So I think you could probably parse out what those are going to be. I'll go ahead and tell you a couple of other things to sort of allay some concerns. This exam does not heavily go into the 3rd dimension, because a lot of what we've been covering since exam 2 has been very 2-dimensional. There has been, we had one centroids assignment where we did the centroid of that bracket that was like in 3D, where I had you all vote on, what direction you wanted to determine the centroid and whatnot. But other than that, I mean, mostly what we've been doing is in the 2 dimensions. So there is that. And number 2, I've really tried to do my best to ensure that this isn't a time crunch. I mean, I know that's probably a concern that you have, with some of the homeworks and the exam problems that you've done. I've really tried to make the problems manageable and contained. So that's just something to keep in mind. Obviously you want to be organized and moving through the exam, but as I've tried to formulate the problems to accommodate that. In terms of some review content, the rest of this presentation is just formulas. Now let me say this, like I said, I'm not foraying too heavily into the 3rd dimension. That doesn't mean that you don't need to understand concepts related to the 3rd dimension, because there are conceptual questions on the exam as well. And so I might ask some short answer questions on 3D. So I don't want you to ignore it. I'm just saying that we only have 50 minutes, and the last thing I want is I don't want to focus too heavily on that one topic because we got a lot of other stuff to cover. Make sure that you understand the concepts of moments of area. So, the integral of dA is your area. The integral of xdA is your first moment of area. We use the first moment of area to determine centroids. The second moment of area is used to determine the moment of inertia. The second moment of area is the moment of inertia. I went ahead and threw this slide. When in our lecture notes for centroids, this slide popped up a lot. It was just the 2D centroidal reference table. This is not a comprehensive list, and so I don't want you to look at this and say this is all I need to know. But this is your textbook. It's in the NCES reference manual. I don't have a problem with you finding additional centroid references. But just make sure that you know where they are in the book. Make sure you have them available, because I'll just tell you, centroids is a part of this exam, and this is a necessary tool. So make sure you have this readily available, because I don't think it's a spoiler alert to say that you're going to be using this on the exam. I did went ahead and include the 3D centroid references just for completion's sake. But again, as I said, we're not delving too far into the 3rd dimension on this exam. And I'll go ahead and tell you that our final topic in this class, which is friction, doesn't delve too heavily in the 3rd dimension as well. I know that doesn't really have too much to do with our exam, but friction isn't really a massively 3D topic. It's largely a 2D topic. But I thought I'd throw that out there. I went ahead and threw the formula or the algorithm for determining the moment of inertia using the parallel axis theorem. The hardest part, I'd say, is probably your d distances, but that's just y minus the y bar for each shape. References for moments of inertia as well. Probably not a bad idea to have that available also. And then we're getting into the structural analysis component. So just the data or the description of the method of joints, the method of sections. And then the last few slides are on the derivation and the derived relationship between loads, shears, and moments when you construct your shear diagram. So this is our derived relationship. These are the conclusions that we made for our graphical approach, you know, like between shear and moment. If you compute the area under the shear diagram, that gives you the moment diagram, all of that. And then our methodology for constructing shear and moment diagrams for regions subjected to concentrated loads and for regions subjected to distributed loads. And that's the review slides. That's pretty much it. So yeah, that's going to be it for what's covered on the third exam. And with that, I'm just going to turn it over to you and see what questions you have and see if there's anything I can address. Floor is yours. We can. I'm afraid during the review, well, we can, and I see a couple people agreeing with that. I'm afraid during review that a quick joints problem will turn into the entire review, and that's fine. I have no problem with that. But if there's any shorter questions, then I want to give those their time as well. And I mean, if there aren't any, we'll do a joints problem, and that'll be the review. Give me 1 second. So now we've got some contention. Tell you what we probably could do is we could probably pick a single truss and look at both methods. That we could do, but I can go ahead and tell you that's going to take the rest of the class period. So if there's any other questions about any other topics on the exam, I'd ask them like now. And while you're doing that, I'm going to get prepared for this. I'm actually going to use a different book so that I'm using unique material. You're good with the joints problem. Anybody else? Speak now. Okay, give me 1 second. I want to find a good problem. I think that's a good problem. Thank you. I'm a fan of their coffee. Okay, I'm not hearing anything. So this is what we're doing. We're going to do a truss problem. Okay. Give me a second. Let me get this pulled up. Oh, come on. My OneNote's not liking me. Give me a sec. Forgive me, between this class and another class that I teach, I want to make sure that I'm doing a truss problem that is like unique. So if this is too alike to something that we've already done in here, my apologies. But when you do this all the time like I do, sometimes sometimes it can bleed together. All right, so give me 1 second. Let me share the screen because that would help. Okay. So here's the problem I'm going to go with. So bear with me. Actually, hold on. Actually, let me see. Raise that a little higher. Sorry, I'm trying to make this neat. Okay. Okay. First off, before I continue, is this unique enough? Is this a good problem? Okay, good. All right, so this is a truss that's an overhanging truss. The dimensions on this are, this is 12 feet. This is also 12 feet. And these dimensions here are 5 feet. Okay, so yeah, so this is going to be our problem. Before we delve into this, because we've had requests to do both method of joints and method of sections, I'm probably going to go somewhat expeditiously through this problem. So like as I'm going through this, I'm going to try and take pauses and see if people have questions, but at the same time, I'm going to be moving a little bit. Are you going to tell us which method to use on the exam? Great question. No. And the reason I'm not going to is because if you go through the notes, you will see that one method is better than the other for particular goals. Okay. So one method's good if you're trying to reach one goal, one method's good if you're trying to reach another. So instead of saying, I'll tell you which method, I'm going to tell you what I want, and then it's going to be your job to try and figure out what method is best for that goal. And that's going to be my first answer. My second answer is when you see the problem on the exam, and I don't want to reveal too much, but when you see the problem on the exam, I think you'll know what I mean. You'll get it. I don't want to say any more than that because then at that point I'm literally telling you what's on the exam. Okay. All right. So with that, so first thing we need to do is we need to compute the support reactions. So there's going to be a reaction here. This is an EY. There's going to be a reaction here. This is EX, and there's going to be a reaction here. That's AX. So that's a roller, so it only has one reaction in the direction of the roller. And so the roller is facing left to right, so it's going to have a horizontal reaction. Now, first thing I'm going to do is I'm going to compute the vertical reaction, and that's going to be pretty easy. If I sum forces in the Y direction, I've got 10 going down and 10 going down. So EY has to be 20 kips going up. Or maybe I'll write the kip out. So kips upwards. So that's going to go up like that. Okay, and that's going to be 20 kips. Okay. I'm assuming it doesn't matter which direction you look when cutting sections of trusses like in homework 6.2. It ultimately does not matter because equilibrium doesn't care which direction you analyze. Now, that being said, there are advantageous way or directions in which to look. So let me say it like this. There is nothing stopping you from a section analysis cutting a section through here. It really wouldn't be necessary, because if it was me, I would just, use a method of joints, for something like this. But for the sake of discussion, if I cut a section here, I could look to the right or look to the left. And what I would do is look to the right, because there's a whole lot less going on looking to the right than there is looking to the left. So again, equilibrium doesn't care. Physics doesn't care. You'll get the same answer. But just because equilibrium doesn't care, physics doesn't care, doesn't mean that the amount of lead that your pencil expends on the paper won't care. Like, one of these is just going to be less work. Okay, so I tend to look towards the direction that's going to make the problem faster for me. So I tend to be lazy in my calculations. Just look towards the simplest direction. If you have a truss that's like this, and you got members all over the place, and I'm just being really sloppy here, all members all over the place, and you're trying to determine a section through here, I would cut a section and look to the right, because there's less going on to the right than there is to the left. So again, be lazy in your analysis. Okay. And again, fire these questions away as I'm doing this math. This is your review time, so don't hesitate. Okay. So I got 20 down, so 20 up, and so now I need to sum moments. Okay. I'm going to sum moments about E. It doesn't really matter. And so sum moments that way. Okay, so summing moments at E, I've got, let's see, 10 kips, which is negative, times 12 feet, minus 10 kips, times 24 feet. And then the AX is going to have to resist that. So that's going to have to go like that. So AX is going to be plus AX times 10 feet is 0. So 10 times 12 is 120. 10 times 24 is 240. So that's minus 360 equals negative AX times 10 feet. So AX is 36 kips going that way. And if AX is 36 kips that way, there's no other horizontal forces. So the sum of the forces in the X direction equals 0. Tells me that EX is 36 kips going that way. So that's a force couple, equal and opposite. All right. So this is 36 kips. This is 36 kips. All right. Is everybody okay with that? Are there any questions before I move on? Because that you got to be able to do for trusses, for shear and moment. If you can't do the reactions, that's going to be a challenge. Or if you can't compute the support reactions. Okay. All right. So we're going to take this truss and we're going to do it two different ways. We're going to do the method of joints and we're going to do the method of sections. So let's do the method of joints first. Here, let me write something down real quick because I don't want to scroll a bunch. So I'm just cheating and writing down the reactions for me as a shortcut. Okay. So first off, the method of joints. Now, before I do the method of joints, the first thing I want to indicate what, hold on, what? Well, it's going to the left, yes. If you consider negative, yeah. I mean, I guess you could say that, yes. The one thing I want to clarify, whenever you start expressing forces and you start expressing directions and results, is it's okay during the math to treat values as positive or negative. That's fine. But what matters and what's really going to matter from an engineering perspective is the context. See, in your comment, you said that EX has to be negative. Well, yeah, EX is negative if you consider positive forces to the right. What I really care about is that EX equals 36 kips to the left. Okay, that's what matters. Just like when you look at internal forces, it's not about positives and negatives or left, right, up, and down. Is it tension or is it compression? That's what matters. So just make sure that you always apply that contextual explanation at the end. Is it tension? Is it compression? Is it left or is it right? Is it up or is it down? Because that's really what matters, and that's what's uncontrovertible. See, whether or not it's left or right, it is not ambiguous. But whether it's negative or positive depends on what you consider to be positive or negative. That's why the arrows matter. Okay, let's look at our method of joints. So I'm going to do what I did before, and I'm going to sort of split this up. Let's do it like that. Okay. Now, when I do this, one of the things that I sort of glossed over with this example is if you look at all of the diagonals are at a 5 to 12 slope ratio. Okay. So on this problem, like you could see, they all go over 5 and up 12. So, over 12 and up 5. I said that backwards. So because they're at a 5 to 12 slope ratio, does anybody know what the hypotenuse is on a 5-12 triangle? I'm just curious. 13, yes. Like a 3, 4, 5, a 5, 12, 13 is a special triangle. So there you go. Okay, let me start off by putting my my diagonals here. Or sorry, not my diagonals, my members. Okay, so there's my members. Next thing I'm going to do is put my applied loads. And the next thing I'm going to do is put my support reactions. So we got this was 20 kips. This 36 kips. And this 36 kips. Now, I apologize. This is my last time I'm going to scroll up and down. Just making sure I remembered how I labeled them, right? So this was A, B, C, D, E. Sorry for the scrolling up and down. I'm really trying to not do that. I couldn't remember how I labeled them because they're labeled a little differently than they are here in this book, but I thought this made a little bit more sense. Okay. All right, so this is our problem. Now, who in chat can help me out with something? When you're doing a method of joints analysis, what's your limit on your joints? Oh, I forgot one. There's a member right here. Who remembers the limit? There's a limit on when you do a joint analysis. Two per 2D joint. So exactly. So when I start my analysis, I cannot start right here. I cannot start there. There's too many unknowns. I've got 4 members. That doesn't mean I can't solve joint D. I just can't solve it now, right? What are the 2 joints that I can solve right now? E and C, all right? So it doesn't really matter which one we start with. I'm going to just make an executive decision and say we're going to start at joint C, okay? So joint C has 1 horizontal unknown here, and then it has 1 horizontal, 1 vertical right there, okay? So let's sort of track this out. If I've got 10 down, 10 up. Let's talk about this horizontal. And we're talking about this one right here. All right. Somebody help me out. What direction is that pointing? Is it going to point to the left or is it going to point to the right? The one on that diagonal. Points to the left. Points to the left. That's exactly right. And here's why. Okay, here's the line of action. Here, I'll use a solid line here. Think about it this way. Okay, so imagine that's the line of action. Okay, I start at a point on that line of action and I go up 10 kips. If I draw that arrow to the right, I will never hit the line of action ever again. However, if I draw that tip to tail to the left, I will then go back to the line of action, right? Remember that tip to tail vector addition stuff we did at the very beginning of the semester, right? You have, so if I jump up, I go over. Now look, I kind of also drew this to scale, right? And if I drew this to scale, this vector looks like it's much bigger than 10 kips. It is much bigger than 10 kips. Can anybody tell me how much that vector is going to be? It's 24. It's 10 kips times 12 over 5. Exactly right. So this is 24 kips. Here, I'll just use the K because I'm a little lazy. And how do you get that? It's 10 kips times 12 over 5. That's exactly right. Okay, and so now I can go back to the joint and I can say, is 20 the other, well, it's to the right. Yeah, it's to, you're right. Yeah, this one, you stole my thunder. Yeah, but that's 24 kips to the right. It's exactly right. Now, before I start moving on to other joints, I want to make sure this joint made sense. Is everybody okay with this? Okay. All right. And if anybody has any questions, good. If anybody has any questions, you let me know. Now, what I'm going to do is I'm going to start transposing the results onto the adjacent joints, right? So this one's going to be 24 kips. This one's going to be 10 kips, right? And then remember, when you go to the next joint, opposite directions. 10 up means 10 down. 10 to the left means 10 to the right. Again, think of that tug of war example, right? Equal and opposite, equal and opposite. This one right here, 24 to the right, 24 to the left, right? And I'm using a different color for those because what I'm trying to do is track, you know, okay, when I look at, let's say, joint B, I knew the 24 kips from the adjacent joint over on the right. So yeah. Okay. Now, I want you to look at the truss right now and tell me which joints, plural, I could do right now. Now, we had said joint E before. There you go. We could do joint B right now. And I don't know about you, but I like to do joints that have less diagonals going on because there's less to figure out. I can move faster through the problem. In other words, look at joint B. 10 down, 10 up. 24 to the left, 24 to the right. Done. That joint's done. And then now, transpose the results. Transpose the results. And I can move on. I find it a lot easier to do those types of joints quick. When I'm doing a truss analysis and I see joints like that, I just knock them out and do them quick. Okay. Now I've been putting it off. Let's go ahead and do this joint E, this one up here up top. Let's do that one right there. So I've got a vertical here, a horizontal, and a vertical. Okay. So I've got two vertical unknowns, one horizontal. Let's do that horizontal. I got 36 going to the left, 36 going to the right. Now, somebody tell me what that is. Somebody tell me the magnitude and somebody else tell me the direction. So those of you without a calculator, which you should have a calculator, 15. 15 sounds right. And what's the direction? Somebody else. Down. There you go. 15 down. Now, AE, that remaining vertical. Anybody know what that is? 5. That's exactly right. Because I got 20 up. I got 15 down. I need another 5 going down. Boom. Exactly right. Transpose those results. So we've got 15 up, 36 in that direction. We've got 5 going like that. Now, what I'll do is I'm going to look at joint A, because with joint A, I only have that and that. Here's the nice thing when you have a truss like this. If you handle each of those independently, right? I've got 36. So how about, let's take the vertical. 5 up, 5 down. What about the horizontals? I got 36 to the right, 24 to the left. I need another 12 to the left. When you look at that last joint serves to check your answer, because not only are the two arrows pointing in the correct direction, but look at the values. If you treat each of them independently, you get 5 and 12, and that comports with the slope ratio that they have to achieve. And that's the nice thing about a joint or a method of joint analysis, is that it self-checks. Like when you do the math, it self-checks. How did you get 15 again? Oh, are you talking about that one right there? Okay, so give me one sec. So here's the member, and we had that this was 36, right? And so how do you get that? Well, we're going to take 36 and we're going to multiply it by one of two things, either 12 over 5 or 5 over 12. And you can see from the slope ratio that what we would need to do is multiply it by 5 over 12, because that leg's going to be the smaller one. And so 36 times 5 over 12 is 5 times what? 36 over 12 is 3, which is 15. So I'm just using, all I'm doing is using the slope ratio. No, that's fine. That's why we're here. Yeah. So if there's any questions about that stuff, let me know. Oh, no, that's fine. That's fine. We'll still probably take a look at this method of sections because I still think it's beneficial. I'm sorry. I'll try and get this posted to YouTube as soon as I can. Okay, one final thing I want to do is I want to look at this member. So this is 12 kips. This is 5 kips. If you look at this last joint, and again, follow my color scheme here, there's nothing to do on this joint because it's completely solved. We already know all the forces, but just look at the values. It's really, really slick how everything matches up, okay? Look at this. Look at your verticals, okay? Watch your verticals. Look at this. This goes up, that goes up. 20 going up, 10, 20 going down. What about your horizontals? 12, 24 to the right, 36 to the left. Everything matches. It's so cool how that works out, that in the end it all balances. Statics. That's sort of the focus of what we're doing here. Oh. Trying to delete these highlights. Oh, I'm making a mess. I think I got that right. There we go. Okay, so that's our truss analysis. And so if you wanted to start labeling these, let me show you how you would label it. Okay, so right? So let's handle the horizontals and the verticals first. So let's start with this member, BC. Okay, member BC, we know that the magnitude is 24 kips. The question is, does member BC experience tension or compression? I'm asking you. All right, we got a tension. Now that is incorrect, okay? The reason why is, you know, here's the joint, here's the joint. Both of those 24 kips are pushing on the joint, right? Yeah, I said BC. I'm sorry, maybe I was looking at the wrong, maybe I was saying the wrong member. See, if you have a truss member in your hand, so like if you see me on the camera, I've got a member in my hand. Now imagine if I wanted to apply compression. I'm going to push on the member. What's happening on my hands? The member is pushing back on my hands. So those 24 kips, they're pushing on the joints. Member BC is 24 kips in compression, right? I'm talking about this is B, this is C, this is A, E, and D. So that's what I'm talking about. I'm talking about labeling the tension or compression. Does that make sense, Mr. Ball? Okay, well then I'm gonna test you on that. All right, how about member AE? What's member AE? No, member AE, we're talking about, so for member AE, I'm talking about this member right here. Okay? So what Mr. Darrow said is right. The arrows are yanking away from the joint. They're yanking away from the joint. This is 5 kips in tension. There we go. That's what I like to see. All right. So let's try another one. All right. BD. Somebody help me out with member BD. What's BD experiencing? It's experiencing tension, and how much? There we go. 10 kips in tension. So in order to summarize your answer, this is what you're doing. You're just going to each member and identifying whether or not it's experiencing tension or compression and how much. So member AB is experiencing 24 kips, and it's 24 kips in compression. So that's going to be 24. As for the remaining members, which are diagonals, just break out the Pythagorean theorem, right? So like, for instance, member AD, right? Member AD is a diagonal member. First off, member AD, let's test this out. Is member AD experiencing compression, or is member AD experiencing tension? So tension or compression? Compression, exactly right. And as for how much, just use the Pythagorean theorem. What is the square root of 5 squared plus 12 squared? And what do you get? 13. Boom. And so you just keep doing this, right? And so you're getting here. I think this one's 26. And then for DE, I think that ends up being 39. Oh, I got the air. That's not tension or compression. That's tension. And this one's tension as well. And boom, there's your truss solved. That's all the internal forces and all the members. Now we're running short on time. I could try and knock out a super quick sections analysis, but we're probably going to bleed over a little bit. So I was a little afraid of that. But does this make sense? This is important. Like, everybody seemed to want to see this. Even the one person who said they wanted to see method of sections actually just wanted to see this. So and so I guess if you wanted all the forces and all the members, I guess that's your answer. Good. That's what we're here for. That's what I like to see. Any other questions? All right, we're really pushing it on time. I don't know. I'll be honest. I don't know that I can really effectively do this method of sections problem. But if there's anything else that I can clear up really quickly, I'd be happy to. I think this was valuable though, because I think there was a lot of people who were interested in seeing this, and I think this really helped out. Any other quick questions? I feel like I'm getting let off easy. One thing that you can do to sort of tie a knot on this whole thing is, if you want, you could go back to this problem and you could say, what would happen if I cut a section? And like, here's a challenge for you. Cut a section, look to the right. All right. And I'm challenging you. That's the whole point. And if you cut a section, look to the right, and try and solve for those 3 members that cross the section, you already have the answers down here. Like, we've already figured them out. So cut a section and see if you can come up with the same answers I did. So there's a challenge for you, for those of you interested in doing method of sections, because the answer's already figured out. All right. Any questions before we call it? All right, everyone. I'll have this video uploaded as soon as possible, as soon as it processes. If anybody has any questions, let me know. But you all know when the exam starts. I'm not going to see you all until after break because I'll grade the exam and post on Teams, but we won't have class till after break. So I wish everybody a relaxing Thanksgiving break. You won't have any homework in my class, so take it easy if you can. We'll be back on November 30th, everyone. I'll see you then, and best of luck on the exam. Same to you. Sorry about that. I do have to give the exam. All right, we'll see you.